Hello. So today's topic is high frequency inductor. So it is my session 7. So aim of this session is to familiarize with the high frequency inductors. Instruction objective is here we are giving the thing about RF behavior of inductors. We will describe about problems associated with the inductor and construction minimize parasitic effect. The learning outcomes are how does an ordinary inductor behaves at a microwave frequency and understand with a signal in different fields. So if you are coming to straight wire inductor, so if it is a straight wire inductor, it produces the electromagnetic field, magnetic field on this if you are sending a AC. So that is the most important thing whatever I have written. So if you are telling about AC, then without DC, so then we can give the reverse direction current will come according to the Lenz's law. This produces an induced voltage in the wire that opposes and changes in the current flow. So that is known as self-inductance. It is for the high frequency application. If you are coming to low DC, then DC will not pass through the inductor. Now if you have given a description here, so here it is a conductor, and along the conductor around the conductor the voltages are EMFs are produces due to what? Due to the thing is if you are giving the AC voltage. If AC means high frequency AC, not low frequency. If high frequency AC will come, and due to this we are getting the inductive effect. So that is most important here. Because of all conductors including hookup wires, capacitor leads, winding wires, and all interconnected tends to become inductors and exhibits the property of inductance. So here I have given a high frequency equivalent circuit. So if it is inductor, then there is a stray resistance and stray capacitance, and you can see that if you have a cable, then it have the what is that? If in between this space, so due to this space the capaciting effect will coming into existence. If it is a conductor, the resistive effect coming into existence. And if you are coming to L, that means it is itself a inductor. So for that L. So if you are thinking about to C, this C will taken care of. If it is a resistance, then this resistance, and inductor itself it is giving the inductance. And it is generally using for the transistor biasing network. A coil is generally formed by winding a straight wire on a cylindrical form. Winding represent an inductance in addition to the frequency dependent wire resistance. The adjacently positioned wires constitute separated moving charges, thus giving rise to parasitic capacitance effect. Okay, so this is whatever I am talking about it. Now if you are thinking about the examples, if you are thinking about low frequency and high frequency, I have taken the transmission line. As everywhere we are conducting, we are going to conduct the information, that means the signal is conducting from one place to another through the transmission line if you are thinking about the high frequency. So if low frequency, this itself it is a wire, two wires, and it behaves like an resistance only. But if you are thinking about high frequency, then it have resistance, inductance, conductance, and capacitance. Why? Because if you are thinking about two wires, in between there is some dielectric, so for that capacitor will comes to existence. If you are thinking about these two, and there is a leakage current, so due to that this will happen. And if you are coming to resistance, then this will happen. And if you are taking the conductors, this is nothing but the wires, and it is behaves like an cylinder. So cylinder are in a high frequency is represented as your inductance. So it is all about the inductive effect. So self-assessment questions are, these are the self-assessment questions. You just prepare and tell me the answers, and then these are the terminal questions. Okay, and these are the reference books, and thank you.